This is Meet Sean, where we break down real life topics insurance, annuities, real estate, travel planning, and home ownership so you can make smarter moves. Subscribe so you don't miss the next episode.
I want you to picture the roof over your head right now.
Okay.
If you're in a typical, suburban house, it's probably got a peak, a nice triangle.
Right.
Rain hits it, gravity takes over, and the water just slides right off. It's simple.
It's the path of least resistance. Yeah. Humans figured that one out a very long time ago.
Exactly. But now, switch gears. Picture a flat roof, maybe on a modern house or that extension you built, or like almost every single commercial building you've ever been in.
Sure.
It looks sleek, it looks modern.
Yeah.
But if you stop and think about the physics for just a second, isn't a flat roof sort of fighting a war against nature that it's designed to lose?
That is a dramatic way to put it, but you're not wrong. Not at all.
Oh.
When you build flat, you are taking away gravity's biggest advantage. You're essentially building a platform for water to just sit there. And if you don't have some very specific, very clever engineering in play, well, you aren't building a roof.
You're building a swimming pool.
You're building a swimming pool directly above your living room.
Which is a terrifying thought. And that is exactly what we are unpacking today. We're doing a deep dive into a technical report from the WSV Group. It was written by Sean back in January of 2026.
Right. And the title is Flat Roof Drainage Problems, the Hidden Cause of Leaks.
It sounds so dry.
I know what you're thinking. Drainage. Really. But trust me, this report is fascinating because it takes something we completely ignore, how water leaves a building, and shows it to be this incredibly complex, high-stakes system.
So today we're going to talk about a silent killer called ponding water. We're going to decode some great jargon. I'm looking at scuppers and tapered insulation.
Yeah.
And we're going to figure out why a report from 2026 is warning us that in today's economy, ignoring your roof is, well, it's basically financial suicide.
It really is. It's an economic issue just as much as it's a structural one.
So let's start with the villain of this story. The report, it identifies one major overarching problem. They call it ponding water.
Right. And the term is deceptive because pond sounds nice, it sounds peaceful.
Imagine ducks, maybe.
Exactly, lily pads. But in roofing, it is a complete disaster.
So define it for us. Is it just a puddle?
Technically, yes. But specifically, it's water that gathers on your roof and just doesn't leave. The industry standard usually says it's ponding if water's still there more than 48 hours after the rain stops.
Okay, but here's the thing I don't get. It's a flat roof. Doesn't water just naturally sit on a flat surface?
It does.
If I pour water on my kitchen table, it doesn't run off unless I tip the table.
And that right there is the biggest misconception in construction. A so-called flat roof should never be perfectly mathematically flat.
Huh?
If it were, you would have exactly the problem you just described. The water would have zero incentive to go anywhere.
So a flat roof is a lie.
It's an illusion. A properly designed flat roof is actually a very low-slope roof.
Yeah.
It's engineered to look flat from the street, but up close, it's designed to handle water. It has to guide that water to an exit.
And if it doesn't?
If it doesn't and that water sits there, that's when the clock starts ticking.
The report mentions that this ponding leads to leaks, which, okay, that's obvious.
Okay.
But then it drops a phrase that scared me a lot more. Structural damage.
Yeah, that's the escalation.
Leaks are annoying. I get it. I put a bucket down.
Yeah.
But structural damage, that sounds like the building could fall down. Is that hyperbole?
It is not. Think about the weight of water. Do you have any idea how much a gallon of water weighs?
Not off the top of my head. 5 pounds? Maybe.
It's about 8.34 pounds, so let's just do some quick math.
Okay.
If you have a 10-foot by 10-foot area of your roof, which isn't that big, barely the size of a bedroom, and it's holding just 1 inch of water, you're talking about hundreds and hundreds of pounds of dead weight.
Wow.
Just sitting on beams that might not be designed for it.
And that's only 1 inch.
Exactly. Now imagine a clogged drain during a heavy storm. That water rises to 3-4 inches. Suddenly you have literally a ton, 2,000 pounds of extra weight pressing down in one spot.
Oh my.
The wood starts to bow. The concrete starts to stress. It's not just about getting wet anymore. It's about the building crushing itself under the weight of the rain.
That puts a whole new spin on checking for leaks.
Yeah.
You're really checking for, like, load-bearing failure.
Precisely. And the WSV report makes this critical point. The roof has one job: get the water away from the building. If ponding is happening, the roof isn't just dirty, it's failing its primary function.
So if the goal is to move the water, how does a flat roof do it? It needs specific tools. The report breaks down the hardware into two main players, roof drains and scuppers.
Hardware of defense, yep.
Let's start with roof drains. The text says they sit on the roof to catch and move water. To me, that just sounds like a bathtub drain. Is it more complex?
That's actually the best analogy, is the bathtub model. You put a drain at the lowest point on the roof.
Right.
It usually has a little strainer, looks kind of like a water cage, to stop leaves and stuff from getting in.
Yeah.
That drain connects to pipes that run inside your building, down through the walls and out to the ground.
Okay, simple enough. Pull the plug, water goes down. But then there's this other term, scuppers.
I love this word.
It sounds nautical, like something on a pirate ship. Oper the scuppers.
It is nautical. On a ship, scuppers are holes in the side of the deck that let seawater drain back out so the ship doesn't, sink.
So it's the same idea.
In architecture, it's the exact same concept.
So if I'm visualizing this, let's say my flat roof has a little low wall around the edge.
That's called a parapet wall.
A parapet, right.
Yeah.
So a scupper is just a hole punched through that wall.
Essentially, yes. It's an opening that lets water flow horizontally off the roof, through the wall, and usually into a downspout on the outside of the building.
So you have drains that go down and scuppers that go out. Why do you need both?
Redundancy, mostly. You often see a building use both. You might have the internal drains as your main system because they're efficient, but then you have scuppers positioned slightly higher up the wall as an emergency overflow.
Oh, like the little hole near the top of my bathroom sink.
That's it, exactly. If the main drain gets clogged with leaves, the water rises until it hits the scupper and then it pours out the side instead of flooding the building. It's a fail-safe.
But the WSV Group report, it highlights that these are the choke points.
They are. Think about it. You have a massive roof surface area, thousands of square feet collecting rain, and all of that water has to exit through a hole maybe the size of a dinner plate.
That's a huge bottleneck.
It's a massive vulnerability. The source explicitly lists blocked or broken drains and scuppers as a primary cause of leaks. If a bird builds a nest in your scupper, which happens all the time, your roof transforms.
It stops being a shield.
And it starts being a bathtub. And unlike your bathtub, the roof isn't one solid piece of porcelain. It's layers, it's seams, it's flashing. If you fill that tub up, the water will find a weakness.
It's wild that such a complex problem often comes down to just, clean the leaves out of the hole.
It sounds low-tech, but the report emphasizes maintenance over and over. You can have $1 million roof, but if a $10 plastic bag blows into the drain, you're going to have a flood.
Okay, so we have the hardware, the drains, the scuppers, but this is where the report surprised me. It introduces a hidden hero that I had literally never thought about. It's called tapered insulation.
Ah, yes. Now we are getting into the sophisticated part of the design. This is where the magic really happens.
See, when I hear insulation, I just think of like pink fiberglass fluff in the attic.
Keeping the heat in.
Exactly. But the source says tapered insulation is used to create a slope. Explain that.
Okay, remember we said that a flat roof shouldn't be perfectly flat.
Right.
Well, the problem is the structure of the building, the steel beams, the concrete deck, that part usually is perfectly flat. So how do you get the water to move to those drains?
You can't just hope it gets there.
You can't. So you use the insulation to sculpt the roof. In flat roofing, the insulation isn't soft fluff. It's rigid foam boards. And with tapered insulation, those boards are manufactured at an angle. They're thicker on one end than the other.
Oh, I see. It's like a wedge.
It's a massive puzzle of wedges. When the roofers install it, they lay these boards out in a specific grid, and they are literally terraforming the roof. They build artificial valleys and ridges underneath the final waterproof membrane.
That is so cool. It's like landscaping, but with foam.
It is. The source explains its function is guiding water to drains or scuppers. It's so subtle, if you walked on it, you might not even feel the slope, but water feels it.
But here's the catch. The report implies that if this isn't done right,
It's a total disaster. If the design is wrong, or if a contractor tries to save money by using flat insulation instead of tapered, you have bad drainage baked into the DNA of the building.
so no matter how clean your drains are,
It won't matter. You could have brand new drains, pristine scuppers, but if the insulation isn't sloping the water toward them, the water is just going to sit in a dead spot in the middle of the roof forever.
so the ponding water we talked about at the start, it isn't always a maintenance issue. It could be a geometry problem.
Precisely. And that's why the source lists insulation not sloped enough as a root cause. It's a design failure. And frankly, it's a hidden one. You can't see the insulation once the roof is finished. You only know it's wrong when you see the giant puddle that never goes away.
That feels like a good transition to the bigger picture here.
Yeah.
The report starts talking about the building envelope. It feels like a shift from parts to systems.
This is one of the most important concepts in construction science, period.
The text describes the envelope as a shield against the outside world, which is a great image. But what actually is the envelope?
So the source lists three main components: the roof, the walls, and the foundation.
Okay, so basically the skin of the house.
Right. But the mistake most people make is thinking of them as three separate things. People say, I have a roof problem, or I have a wall problem, but the report stresses their interconnectivity.
So give me an example. How does a roof problem become a wall problem?
Okay, take that scupper we just talked about.
The hole in the wall.
The hole in the wall that drains the roof. If that scupper isn't sealed perfectly, or if water coming out of it blows back against the building, you get water inside the wall cavity.
And then what happens?
And then you have mold growing behind your drywall. You might see a wet spot in your living room and think, I need to fix the wall. But you don't. You have to fix the roof drainage. The roof is attacking the wall.
Or if the downspouts just dump all that water right next to the house.
Then you've got thousands of gallons soaking the soil right next to your foundation. The soil swells, the concrete can crack, and suddenly your basement is flooding. The source says preventing water intrusion requires keeping the entire envelope strong. You can't just patch one hole.
It's like a raincoat. If you have a hole in the hood, your shirt gets wet. It's not a shirt problem.
That's a perfect analogy, and this system thinking is why the source so explicitly advises against trying to figure this all out yourself.
Yeah, I noticed that. There's a pretty strong don't DIY this vibe in the text. It says, if your roof is giving you trouble, get help from the pros.
Look, I'm all for DIY. Go paint your kitchen, build a bookshelf.
Right.
But flat roofing is notoriously unforgiving. If you mess up a pitched roof, it might leak in 10 years. If you seal a flat roof badly, it leaks the next time it rains.
The source for this deep dive, the WSV group, they list a lot of certifications. It's just a whole alphabet soup of licenses.
It is, and looking at those credentials actually tells us a lot about the complexity we're dealing with. They list a roofing license, obviously.
Of course.
But they also list a building license, and this is the interesting one, an HVAC license.
HVAC. Why does an HVAC license matter for a roofer? Are they fixing my AC?
Think about what sits on top of most flat roofs.
Oh, the air conditioning units, the big commercial ones.
Exactly. On a commercial building or even a modern home, all the mechanical equipment is up there. And those units don't just hover, they sit on metal boxes called curbs that penetrate the roof membrane.
So every single AC unit is a potential hole in the roof.
Every single one is a potential leak. Every vent, every fan, every pipe. Having a professional who understands both the roofing membrane and the mechanical equipment on top of it is a huge advantage.
It's that system view again, isn't it?
It is. You need someone who sees the whole envelope. You need a holistic doctor for your building, not just a specialist.
I want to pivot a little to the when of this source. This report is dated January 16, 2026.
Right.
And when you look at the recent posts list in the source material, you see titles like What Actually Drives Construction Costs in 2026 and Why Your Permit Takes So Long.
That context is incredibly important for you, the listener, to understand.
It really paints a picture of a construction environment that is difficult.
Difficult is polite. It paints a picture where replacement is incredibly costly, it's slow, and it's bureaucratic. If permits are taking months and material costs are spiking, you do not want to be in a position where you have to replace your entire roof.
Because you're not just paying for the roof, you're paying for the delay.
You're paying for the delay, you're paying the 2026 premiums on labor, and you might be fighting with insurance the whole time.
So the argument for just doing simple maintenance becomes an economic one.
100%. In a high-cost environment like the one described for 2026, maintenance is your best financial product. Keeping those drains clear, checking the scuppers, that's the most cost-effective investment strategy you have for your building.
It prevents the catastrophic failure that forces you into that whole expensive, slow process.
Exactly. The source notes that regular maintenance is key to extending the lifespan of your flat roof. In a normal year, that's good advice. In 2026, that's essential financial advice. You're buying yourself time.
Okay, so let's bring this all home. We've covered the enemy, the hardware, the hidden tech, the economics. If we had to boil this down for the listener, what are the three lines of defense?
Sure. First, you've got the hardware. That's your roof drains and your scuppers. They're the gateways. If they're blocked, nothing else matters. Keep them clean.
Second.
Second is the slope. That's the tapered insulation. It's the hidden geometry that moves the water. If you have standing water that never goes away, you might have a slope problem, not a clog problem.
And number 3.
The third is the system, the building envelope. You have to understand that your roof, walls, and foundation are one interconnected shield. Protecting the roof protects the foundation. Ignoring the roof destroys the walls.
The actionable advice here seems, well, pretty straightforward.
It is. Don't be passive. If you have a flat roof or you manage a building with one, go look at it.
Look at it.
Yeah. Go up there 48 hours after a good rainstorm. If you see a pond, if you see water reflecting the sky, that is not a feature. That is a failure.
The pond is the warning sign.
It absolutely is. And if you see that pond or you suspect your insulation isn't tapered right, call a pro. Like the WSV Group report says, get expert advice. Don't try to re-engineer the slope of your roof with a bucket of tar from the hardware store.
Right. You need somebody who actually understands the physics of it all.
Exactly.
You know, it's funny. We spend so much time thinking about the inside of our houses. We obsess over paint colors, the kitchen, the smart home stuff.
Yeah.
But this deep dive really made me think. We completely ignore the top of the shield.
It's the most exposed part of the entire building. Think about it. It takes the full heat of the sun in summer.
Right.
It takes the freezing ice in winter, the full force of the wind, the full weight of the rain. It takes more abuse than any other part of your home.
And yet, we usually only think about it when water is dripping on our head.
Which is almost always too late.
It's a sobering thought. How much money are we wasting just by ignoring the basic physics of water flow right over our heads?
Probably a lot more than any of us would like to admit.
Well, on that note, I think I'm going to go borrow a ladder and check my gutters.
A very wise move. Stay safe up there.
Thanks for listening to this deep dive into the surprisingly complex world of flat roofs. We'll catch you on the next one. Stay dry out there.
Goodbye, everyone.
That's it for today's Meet Sean. If this helped, follow the show and share this episode with one person who needs it. See you next time.